Hello, ladies and gentlemen. Welcome to today's review of trigonometry. So, let's start with the basic trig functions. The idea is you have a right triangle, and then you have a select angle using as your base angle. This is a reference angle. Everything in here is with regards to this particular angle here. The sine of any angle is the opposite side over hypotenuse. That's the SO of TOA. And so on this, the opposite side is the one opposite. And then the hypotenuse is the longest side, the side opposite your right angle. So this can be 8/7. Cosine of any old angle is adjacent over hypotenuse. That's the ka of TOA. And then the adjacent one, the adjacent side is the side next to the angle. That's not the hypotenuse. So that's going to be 15/17. Hypotenuse is still the 17 length there. Tangent of any angle is opposite over adjacent. So we got to do the opposite side, 8/adjacent, which is 15. So we got 8/15. These other ones over here are the reciprocals of these ones. So this would be hypotenuse over opposite. This would be hypotenuse over adjacent. And then this one's going to be adjacent over opposite. Oh, by the way, the full names of these are cosecant, secant, and cotangent. Forgot to put that. Which makes the fun alliteration here, not alliteration, the fun acronym of CHO, SHA, and KO, which I find like the last one a lot of fun. Anyway, so these are 7/8 and 17/15 and 15/8. These ones, like they show up more later for this year. We primarily used these ones, but I wanted you to be aware that these ones exist and that they're just these ones flipped upside down. And there you go. So you can use these equations, these setups to help you get unknown values, and that's really what this is getting at. So on your review assignment, which is an assignment due in class called Solve a Triangle, you're solving a triangle, which is getting all the angle measures and all the side lengths. So let's start here by getting all the angles. Luckily, this angle here, which let's just call it y because there's already an x there. Y is going to be 180 minus the angles we already know, minus 90 and minus 49. And voila, you will have how many degrees y is. Let's see, which comes out to be 41? 41 degrees, I think. Yeah, 41. All right, so we got y. Let's switch colors, and let's get this x here. So if you're going to get x, you can set up an equation, a trig equation, that involves an angle you do know, and then a side you know, and then the one you don't. So there's going to be three things in the equation. You want one of them to be something you don't know, and the other two to be knowns. So I'm going to use this angle as my reference point, and I'm going to figure out, so I'm going to have this as my theta, and then I need a equation that uses x and uses this 13. Well, the 13 is the opposite side, and then x is the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So sine of 49 degrees is 13 over x, right? Opposite over hypotenuse. Well, this equation has one unknown, and we're going to solve for it. It's pretty quick. You want to get x out of the bottom, and then from there you want to divide by sine of 49 degrees. That'll cancel. Let me divide that by sine of 49 degrees. And so x is going to be 13 over sine of 49 degrees. And at this point, put in your calculator and get the decimal approximation. All right, let's round to the second decimal place. You should be getting about 17.23. It was 225, rounds up to 23. So there you go. There's that part. There's one more thing we need to get, which is this missing side. And you could use Pythagorean theorem, right? You have this number now, you have this number, so you can do 17.23 squared minus 13 squared and solve that. But I'm going to use trig again because I think we should use trig again. So let's use this again as our theta, this 49. And then we're going to use the opposite side, and then we need to get this adjacent side, which we call z for the time being. And so the trig function that uses opposite and adjacent is tangent. So tangent of 49 degrees is equal to 13 over z. So yeah, it's opposite over adjacent, and adjacent's the side we don't know. Once again, you can switch these just like we did up here. I don't know if you saw the work, but if you times both sides by z and then divide both sides by tangent of 49, it just switches their places. And so you got z is 13 over tangent of 49 degrees. And that is something you can put in your calculator. I do want to make note that you should be making sure your calculator's in degree mode, not radian mode. It changes your answer drastically, so make sure it's 49 degrees and not 49 radians. But take a moment, put it in, see what you get. Alright, should be getting 11.30, or just 11.3. And voila, we have solved this triangle by getting all the side lengths and all the angle measures. Let's do one more so you can see that process again. And I want to show one that it doesn't tell you any of the angles inside, because that requires you to use the inverse trig functions. So let's say we want to find our angle here, angle question mark. Well, the sides we know are the opposite and the hypotenuse, which is sine again. So sine of our question mark is 53 over 55. To solve for question mark, you actually need to get the inverse sine of both sides. So you can do inverse sine of both sides. And what that does is, if you inverse sine a sine, it just gets rid of the signing. So we got question mark. And on the right side is sine, inverse sine of 53 over 55. Use a calculator to get this decimal approximation. It is going to be a decimal approximation, but go ahead and plug it in and see what you get. Alright, you should have gotten 74.50 degrees. Make sure you're in degrees there. If you didn't get that, you might be in radians. And voila, we have got this angle measure right there. Let's also get this other angle measure. Let's call this one x for variable's sake. And let's use an inverse trig function again. We could use the fact that triangles add up to 180 degrees, but I want to show you the inverse thing again. The sides we do know are 53 and then 55 again, but this time in relation to this angle, 53 is adjacent, not opposite. So this is going to be adjacent and hypotenuse, and the trig function that has that is cosine. So the cosine of x is equal to 53 over 55. If you want to get that x value, again, we're going to do inverse cosine. So x is going to be the inverse cosine of 53 over 55. And you can plug that in your calculator and get that approximate value. Alright, you should have gotten about 15.50. I got 15.4987, which rounds up to be 0.50. And voila, we have our other angles. So we got two angles, we got two sides. We just need to find the last thing, which is going to be this side over here. Let's call that y. And let's use Pythagorean theorem to get that. Y squared plus 53 squared is going to equal 55 squared. Remember, a squared plus b squared equals c squared. Let's subtract off the 53 squared. And now we'll have y squared equals. Go ahead and plug in that right side and see what that comes out to be. Alright, I got 216, so let's square root both sides there. This one, you can get about, here, let me type that in real quick, about 14.70, right? That rounds up a little there. And so yeah, we got that last side. So we got both angles, we got that missing side, and yeah, so use your trig equation, set up the equation, and then you can use either your inverse trig function to get angles, or you can solve your equation like this to get an unknown side length. And there you go, there's your review of trig stuff.